Inside your body, right this very second, there's an entire army fighting to keep you alive. But what's stopping that army from turning on you? Today, we're going to dig into the incredible biological failsafe that prevents this, a discovery so profound it just won the Nobel Prize. So let's just start with that big question. Your body has this incredibly powerful immune system, right? An army of cells designed to hunt down and destroy any invader. So what's the off switch? What keeps that same army from turning against your own healthy cells? Well, the answer isn't just some neat biological fact. It's a mechanism so fundamental to our health that finally cracking its code has opened up a whole new world in medicine. And yeah, it earned its discoverers the Nobel Prize.
Okay, let's get into it. This is a story about a huge biological mystery, a really puzzling experiment, and the scientists who just refused to give up until they found the answer.
The prize went to these three brilliant researchers, Dr. Shimon Sakaguchi, Mary E. Brunkow, and Fred Ramsdell. Their work, when you put it all together, solved a puzzle called peripheral immune tolerance, which is really just a fancy way of saying how your body learns to tolerate itself.
So, what is immune tolerance exactly? Think of it like your body's internal self-control system. It's the critical process that teaches your immune cells, hey, this is us, leave it alone, while also keeping them on high alert for actual threats, like viruses and bacteria.
Our story kicks off where a lot of great scientific stories do, with a totally baffling experiment involving some mice. And back in the 1980s, the results from this one experiment had researchers completely scratching their heads. Okay, so let's walk through this, because it's a real head-scratcher. It all starts with the thymus gland. You can think of it as a boot camp for immune cells called T cells, where they learn to ignore the body's own tissues. Now, in this experiment, scientists took the thymus out of newborn mice just 3 days after they were born, figuring that the training was basically done. So you'd think the mice would be protected from their immune system attacking itself, right? But what happened was the complete opposite. Their immune systems went totally haywire and started attacking their own organs. This became the million-dollar question, or, well, the 11 million Swedish kroner question to be exact. Why did this happen? It just flew in the face of everything they thought they knew about how the immune system works. And this single, baffling result would end up driving Dr. Sakaguchi's research for more than a decade. So to find the answer, we have to look a little deeper. It turns out, the body's main training program isn't perfect. It needs a backup plan. It needs a set of brakes to stop things from going completely off the rails. And this was the first huge clue that Dr. Sakaguchi found. That immune system boot camp, the thymus, it's not 100% effective. A few rogue T cells, the ones that could attack the body, always managed to slip through the cracks. So that meant the body had to have evolved some kind of second line of defense to deal with them. And this was the breakthrough. He discovered a whole new kind of T cell, which we now call regulatory T cells, or Tregs for short. Just think of them as the immune system's peacekeepers. Their one and only job is to patrol the body and slam on the brakes if they see any friendly fire, actively stopping other immune cells from making a terrible mistake and attacking our own body. Chasing this radical idea wasn't easy at all. Dr. Sakaguchi ran into a ton of skepticism and had trouble getting funding. As he said himself, "I think my stubbornness led to these results." It's just a great reminder that sometimes the most important science comes from sheer persistence. Okay, so we found the peacekeepers, but that just opens up a whole new mystery. What tells these Tregs what to do? What's the genetic master switch that even creates them in the first place? The answer to that question actually came from two other researchers, Mary Brunkow and Fred Ramsdell. They were studying this one particular strain of mice that had a really devastating autoimmune disease. I mean, their bodies attacked themselves so aggressively, they only lived for a few weeks. They just knew the answer had to be hidden somewhere in their genes. And after years of incredibly detailed work, they found it. The culprit was a single mutated gene they called FOX3. This was it. This was the master switch. The FOX3 gene is basically the instruction manual for creating those Treg peacekeepers. If that gene is broken, the peacekeepers never get made, and the immune system just runs wild. And here's where it all clicked together. The researchers figured out that a mutation in that exact same gene, FOXB3, causes a rare and severe autoimmune disease in humans. It was the same condition they were seeing in their mice. They had found the genetic key to the whole system of immune tolerance. So we've got the peacekeeper cells, and we've got the genetic master switch that controls them. Now, this is all fascinating biology for sure, but the real power of this discovery is how we can now use this knowledge to fight some of our absolute toughest diseases.
This discovery really gives us a whole new level of control, and it's kind of like two sides of the same coin. For autoimmune diseases where your body is attacking itself, the problem is you don't have enough peacekeepers, so the goal is to boost them. But with cancer, it's the total opposite. Tumors are sneaky. They attract too many peacekeepers to act like their own personal bodyguards. In that case, the goal is to block the peacekeepers so our immune system can finally go in and destroy the cancer. And believe me, this isn't just theory. This research has kicked off a massive wave of innovation. Right now, there are more than 200 clinical trials happening for all sorts of things, from cancer to organ transplants, and all of them are based on this idea of controlling these peacekeeper cells.
This quote from Dr. Marcella Maus really just says it all. For decades, the holy grail for scientists was figuring out how to turn the immune system up or down, almost like a thermostat. As she puts it, the work of these laureates unlocked the tolerance side of this equation. We finally have our hands on the controls.
So, the discovery of Tregs and the FOXP3 gene didn't just solve a mystery that was decades old. It's literally paving the way for a whole new generation of medicine. It's an amazing reminder that some of the greatest secrets are still hidden right inside our own cells, which just leaves you with one final thought. What other secrets is our immune system still hiding?